Yes, and that is the closest we get to Africa and to Kampala, unfortunately, this time. Welcome to this finals and awards ceremony for the Kampala INSPIRE hackathon. We thought we would share some virtual impressions of Africa with you to start with. I don't know exactly where they are from, but it's the sound of Africa. Welcome, welcome today. We are all excited. We are here ready to celebrate and enjoy the results of and the fruits, the first harvest actually of the Kampala INSPIRE hackathon. Before we start with the program, and you will get the program in through the chat here, by the way, so there's a long program, but you will get it there. But before we really start, and so that you can all get on board, we will start with the signature of all my online events, namely the weather reports. So what we can start then to get real time, at least from Uganda, representing Africa in this case, is the weather report. So, and you will learn more about the panel here shortly, but we start with the weather report. So Lydia, can you tell us where you are and what the weather is like where you are?
Hello, participants. Lydia here from Uganda, not in Kampala at the moment, but in a district called Mukono. I am at home in one of the rooms in my home. And how is the weather? It is not decided. It wants to rain, it is shiny, it's just in the middle there. But it is cool. It is a good kind of environment. Yeah.
Excellent. We are trying to imagining being there with you, Lydia. And then we can move on and hear from the rest of the panel here what the weather is like, so and where you are. So Sushit, let's go on with you.
Unmute yourself.
Still not unmuted. Okay, then we move to Ian while Sushit is trying to maybe interrupt you, Ian. Let's hear it, where you are and what's the weather like.
Okay, Ian Jarvis, I'm with GeoGlam and I'm here in Switzerland. I'm looking out at partly sunny skies. It's about, I'd say 10 degrees Celsius, and I'm looking upon glaciers and snow and mountains right now.
Lovely. Sounds lovely.
Wow.
And Hanka, how about you?
Hello, greetings from Czechia. When I look outside, I can see partly cloudy, and when I see my meteo station, it says it's 12 degrees of Celsius. So it's a little bit pity that we couldn't travel to Africa to warm up ourselves. But I hope we will make you feel we are actually there. And to make this feeling even better, please turn your heatings on.
Yeah, and Sushit, have you solved the sound issue now so we can hear your weather report? No, we haven't. So I suggest, Sushit, that while I'm giving my weather report, you can go out of the room and come back in here again, and that might solve the sound issue, okay? So, well, my name is Bente Lilja. I am situated right now in Norway, and that's far north in one of the Scandinavian countries, far from Africa. We have a lovely spring weather. We have sunshine and I don't know, 15 degrees, 10, 15 degrees. That's, very warm for us. So Hanka, we don't want to put on the heat. We used to cold. Okay, so we have 10 challenges that we will learn the results from. And the program will maybe, let me see if I can share that with you directly. Yes, I shared it in the chat box. So you see that you get the program in the chat box. You will see each of the challenges turn and the rest of the program as well. You can start to familiarize yourself with the chat by telling us what the weather is like where you are, and do tell us where you are from. We know that there's a lot of people from many different countries in Africa that have participated in this hackathon, but there are people from around the world as well. So it would be very nice to hear from you in the chat box. Okay, so Sushit, it sounds like you are ready to give a report now.
Okay, yes, hope
Yes.
you can hear me now. Thank you. Yeah, so I'm Sujit Anand. I'm now based in Nottingham in the UK, and it's very nice weather here. It's nice and sunny day. Thank you. I'm happy to join you all.
Thank you. Thank you so much. So Hannah here is my co-host. So Hannah and I, we will be hosting this. And Ian, Sushit, and Lilja are comprise the jury of this hackathon. So the Inspire Hackathon, as you will learn, is not really a tough competition sort of hackathon or event. It's more like a family gaming situation where we celebrate the winner, but we are all friends and cooperate and have activities both before and after. So hello everybody. I see that there's Munir tells us that 31 degrees and getting hot day by day. Emmanuel Ayad, I'm sorry for mispronouncing your name, from Sierra Leone, welcome. Hello from Serbia, Marina. And Samuel from Kenya, so nice to see you here. Okay, so the program. We will start with 5 of the results. The presenters will be invited into the room. So this room will be sort of this blank spot that you see is considered to be the stage, the equivalent to the stage. So we will invite the speakers into the room. And it's challenge number 6 who will start, and that's Pavel. So Pavel, can you raise your hand? So this is how it works. The presenters will raise their hand, and we will invite them into the room, and they will give their presentation. Then the jury will be given the possibility to ask them questions. And if you have questions and we have time for it, we can also include them in the program. But it will be short and very intense presentation, so I cannot promise too much, except we have to give priority to the jury members, which are here. Yeah. And yes, I will just invite Pavel so he gets some time to get in here. We have a break mid-time after the 5 first presentations. And in that break, you will get some fun facts. So Hannah has created and collected a lot of statistics, and we think statistics is fun facts. I don't know about you, but we think that's fun. But if you watch in this break, that will be about 5 minutes, I encourage you to run to the restroom if you need to take a break there, and then run back to the webinar room, the room here, because there is a nice surprise at the end of the first video. We will also have a second break after the final 5. Hi, Pavel. Hi, nice to see you.
Hi, Bente. Hi, everybody.
Hi, Pavel.
We will have
Hello.
then the jury will withdraw and discuss the final decision on the top 3 presenters, the teams. And then we will have and that starts sort of the award ceremony. So we will try to have some fun during this. So we encourage you to clap actually after each of the presentations. I will do the clapping like this. And you see, we are celebrating here. This is a typical Norwegian thing. Whenever there's a happy event, we put out the flags. So that's why they are there. And then we have some surprises, some beautiful surprises, I will say, when the jury is working hard. We will be able to enjoy more scenery from Uganda. You will be surprised. I was definitely surprised of the beauty of that country. So this is the virtual Kampala hackathon going on today. And of course, the announcement and the celebration, the final celebration. We plan to do this with the ending about 3 o'clock, plus minus. And I think we are ready to start. Hannah, did I forget something?
I don't think so, Bente.
Okay. Okay, Pavel, I think you will start the show. And we are excited to hear what your work ended up with during this hackathon.
Okay, thank you very much, Jess, for starting my presentation. Do you see my screen right now?
Yes. Can we turn off our cameras also? Can you remember to do that?
Sure. Yeah.
That goes for all of us.
Is it better?
Yes, perfect.
Cool. So thank you for the word, and I would like to welcome everybody here as well. And I will be speaking about the outputs for the challenge number 6, which was dealing with the climate changes trends for agriculture in Africa. I will be speaking on behalf of my team, including Jiří Valeš and Karel Charvat from University of West Bohemia in Plzeň, Czech Republic. What was the idea for Challenge 6? We wanted to perform some calculations for chosen climatic variables suitable for the locality of Africa and present some changes in time at the variables. It's not just for this hackathon. The story about the agroclimatic variables have been with us for last 2 years, as you see through the hackathons starting from INSPIRE Hackathon 2018. And let's get into the workflow of Challenge 6 because we are short in time. First of all, we selected the area where we want to proceed our calculations. We had to choose suitable climatic variables for the area, design the algorithms for these climatic variables, and find the data which are suitable for our algorithms. And then the algorithms were run using Jupyter Notebook, so Python, and the computing platform, the server-side platform of EUXDAT project. And of course, the outputs should have been in a form that everybody can understand, so we provided several outputs of maps and graphs as well. And this is the area. We wanted to be international, so this area was chosen to be between Uganda and Tanzania, as you see. Not the Kampala directly, but we were happy with this area, so we chose this one. We chose these 8 climatic variables which we were discussing about that should or could be suitable for Africa to calculate, to see the outputs. We used the open data, of course, because we wanted to use open data, and we used the climate data store of Copernicus project. Particularly, it was ERA 5 land dataset containing hourly data from 1981 to the present concerning different variables regarding the climate all over the world, not only in the Europe, as the Copernicus is founded by the European Commission, but it's a worldwide data set. And as I said, the coded were implemented in Jupyter Notebook technology using Python and run on server. So we have time for results right now. And from these 8 climatic variables, I will present just a few of them to see how it looks like. The average annual solar radiation in last 3 decades is indicated on this graph for each point dedicated within the data we download it. Because for each point, we get 30 years of data for solar radiation and 10 years of data for any other climatic variables we have chosen. So there is a lot of data to process, to go through, and this is one of the outputs. So agglomerated value, the accumulated or average annual solar radiation for the last 3 decades, decade per decade. The another results is average growing degree unit, for example, for the crops which are in the C3 group of crops, for example, wheat, rice, soybeans, and so on, for the last 10 years. And GDU is an accumulated number which accumulates over the minimum temperature which is necessary for growing a plant. And on the right side, we saw the average numbers of day with the optimal temperatures for C3 crops. As you can see in Africa, there is in this area, there is a larger part of it which is very suitable for this kind of crops. We calculated the same for C4 crops. As you can see, the left side is the same, but the range of the accumulated degrees of Celsius is different. But the right side is very interesting, because for C4 crops like corn or sorghum, which were originated in tropical areas, there is more crucial demanding on temperature than the C3 crops, for example. And getting to one of the most important results, one of them, the trends were aggregated into the decades, but we also wanted to show some trends on the spots within the data. So, for example, when we click on a bottom left or southwest point in this picture, we can provide some statistic graph or linear trend for the data showing the last 10 years of the trend for the data. When we had more data calculated or managed, we could provide several time stamps for last 5 or for decades, last 3 decades or last 6 5-year periods whatsoever. But how can we interpret such data? For example, one of the example is like this. Theoretically, when we know that there is a plant which requires at least 200 days with the optimal temperatures, we could draw an isoline on the map showing that the right side of the picture is suitable for growing the hypothetical plant. The left side is not that much. And a farmer can choose or can show the coordinates of his farm on the map and see whether it's suitable for him to plant the hypothetical plant in here, or if we had a list of plants having the information about what's the optimal temperatures for growing the plant, the farmer can pick from such a list the most suitable plants to plant on his field. This is one of the interpretation we can see from the data. So the time is running and we are getting to the conclusion. What we have done, we were able to design algorithms for 8 chosen climatic variables, which we thought that provide valuable information for African farmers, but not only for them. We succeeded in implementing algorithms on the server side, computing using Jupyter Notebook technology. And we have generated some outputs in the forms of maps and graphs, while the maps are showing the situation in a greater scale of the chosen area, and the graphs showing the trends for particular chosen places. And this is the end of my presentation. I believe I didn't exceeded the time given to me.
Thank you so much. Thank you. Thank you so much, Pavel. You will deserve a...
Thank you very much.
Pavel, great job.
Okay, jury members, do you have a question or two for very quickly to Pavel?
Can I? Yeah, thank you very much, Pavel. Very interesting work, and thank you for your work on this. Just an observation, really. So, were there any local mentors in your team for the team you were part of?
The Samuel Ekwaku was part of the team.
Mm-hmm.
And he's from Kenya, I believe.
Okay, good. Okay, I think that's really good. So I think it's a really good example for even continuing, having this capacity development aspects for the future as well. So thank you for confirming this. Thank you.
Our pleasure.
Yes, Lydia? You need to unmute.
Thank you for the presentation.
My pleasure.
Yes, I have two issues, maybe comments or questions, depends on how you'll take them. The first is applicability for our local farmers deep in the villages here in Uganda. When you talk about GPS coordinates or, positioning themselves, it's a bit too abstract. And the second is prediction. I know it is possible to predict this for the coming years. You have worked on the decades past, coming years. Is that in plan? Have you considered furthering your challenge to, predict? Thank you.
Okay. Thank you for the comments or questions. I would like to start from the second one. We know that historical data cannot be used for forecasting in a larger scale, let's say. We know that the trends are changing. When we see the data, the temperatures is rising, but not as a linear trend, but somehow exponentially. But we don't know yet how much. So we could use such data for forecasting, but we don't know yet how it really works in the future. And the first question about the coordinates. As you saw, the area is very large. The scale or the range of the points we used is like 1/10 of a degree. So in the Central Africa, it's about 11.5 kilometers. So I believe a local farmer can find its farmer within the grid of 11.5 times 11.5 kilometers. It's not like the precise information for a particular field. It's information about the trends within the last 10 years at the area. I hope well.
Yeah, but you point, I think you, Lydia, what you also pointed to is that the concept of position, maybe when you communicate with the local farmer, is maybe different depending on a bit on the culture. Is that what you also meant by the GPS coordinates?
Yeah.
So this is So this is what we learned through these hackathons, and where we engage actually with the local people using it or having the pain points. So this is one of the great outcomes of the Inspire Hackathon in Africa, in my opinion. So I think we need to say goodbye to you, Pavel.
Thank you very much, Pavel.
Thank you so much. I am not sure. I have somebody raising their hand, but
It's
I'm not
Dima.
sure. It's Dima.
It's Dima.
Okay.
Yeah, it's him.
Okay, I did so.
Yeah, and just for your information, I've just started running a poll, so please tell us where you come from and share this information with us.
Yes. So, well, I got another Dima. Well, I got the Dmitri, and I trust that's also Dmitri. So we will learn about open land use. That's the next challenge, open land use for Africa. And I think there are room for some questions why Dmitri is on his way in here. Now, here he comes. Excellent. No time. We will see Dmitri very soon. Hi.
Hello, Dima. Hi.
Welcome.
Do you hear me? Yeah.
Yes.
So my
we hear
microphone works.
you. Yes. Okay. I think we just jump to your presentation straight away. You can tell us a little bit who you are, of course, before.
Well, I think we had about 2 webinars before where I was presenting, but who doesn't know? My name is Dmitri Kozhuch, and I work for Plan for All Association. And in this Kampala hackathon, I was involved in, for example, the most in work of team number 3, which was basically exploring the ways to improve open land use data set and explore it and expand it to cover also African countries.
Yeah. Yes, excellent.
Thank you for the introduction, Dima, and the floor is yours.
Okay, so maybe I will switch to presentation mode.
Yeah, and turn off your camera, yes, you know.
So as I was telling, I was working on the most about open land use map improvement, and there were a number of people in the team, and actually because this challenge is very related to the challenge of the Dubrovnik hackathon, which ends on 11th of June. We will continue to work until 11th of June. So basically it was me, Sofia from Greece, Mamadou from Central African Republic, Akin from Turkey, and Stella Maris, who is involved in the work. And the goals that we had, it was to explore available data sources for getting information about land use and land cover in Africa. Then we also, because the database is structured by administrative units, we needed also to collect the structure of administrative division in all Africa, and then also because sometimes the data sources is very much out of date, we needed to explore the potential to use satellite imagery, which is becoming increasingly available to identify land use and land cover in Africa. So let's start with the first goal. It was dataset collection. This work, it was more or less done even maybe just first week when the hackathon has started. So we collected AfriCover project data. It is the data basically collected in the beginning of 2000s, in the end of 1990s by FAO organization. It maps mostly East Africa. But the data is very much out of date since it was collected 20 years ago. Then is this ESA data, which basically created land cover map of Africa with resolution of 20 meters based on Sentinel imagery in 2016. Then it's the data that we have extracted from OpenStreetMap, which had land use tag. Then also it is some good quality data from South Africa published by their Department of Environmental Affairs, which is basically a national land cover data set for year 2018. And then we also got some data from Team 2, which was working on SmartAfriHub, and it's data about the harvested areas with different crops. Then this was it, and then we also needed to collect administrative units in Africa to get administrative division, and for this we have been extensively using Wikidata. It's basically the database of data from Wikipedia, which is structured as RDF triples, and it's queried through SparkQL endpoint with the help of SparkQL queries. And for example, here it's some example of how to get, for example, all countries in Africa. Let's say, let me demonstrate you. I was actually speaking about it in a previous webinar, but to demonstrate how easy it is, it's basically you just go to their SparkQL endpoint, you do the query, and here you get basically the list of all countries in Africa, 54 countries. And then after you get the countries, I have created some recursive query which used the property has administrative part, and then I was able, based on this property contains administrative territorial entities, to get all administrative division of Africa with this query. And then because internally we work with PostgreSQL database, I have uploaded this data in our PostgreSQL database, and basically anyone who is registered at Jupyter Hub is able to use this table to query the data. So for example, here if we go to Jupyter Hub, you just import some necessary libraries for Python, then you create the queries. So for example, we want all administrative division of, let's say, Uganda, since we are having Kampala hackathon, then we execute the query. And here is the results. It's basically some table. It's the name of the country, which has administrative level 0 conventionally. And then it's some subparts, and everything is semantic data, meaning that if you it has all unique identifiers that basically you can open and see the information exactly about the unit. Then let's continue. Then also we were collaborating a little bit with the team who was creating interchangeable map compositions. So with this SparkQL queries, I was able to get also statistical data about 20 different statistical parameters. Let's say GDP, then mortality rate, fertility rate, life expectancy, human development index for all these countries, and also I uploaded it, this data to database, and from this data there were some compositions created and published at MapTool. Maybe people will speak more within this team interchangeable map compositions, but this is just an example. It's all data downloaded from Wikipedia, and this composition, it shows GDP in Africa. So let's go back. Then basically the data in Wikipedia doesn't have geometries naturally to the objects, but it has some property which interlinks it with OpenStreetMap registry, and from OpenStreetMap registry you can get the geometry of these objects, which I have done. Then we were also quite interested in exploring how to basically keep open land use database up to date using satellite imagery. So we came with a way to use at first satellite image segmentation. And what it does, it basically takes the image and divides it into objects, and these objects are defined by clustering in n-dimensional space. Basically, it takes into account the spatial coordinate of the pixel and also its color coordinate. There are lots of different color definition systems, for example, RGB, where you have 3 coordinates, one for red, one for green, and one for blue component, but there are also others one. And basically, this algorithm of segmentation is, I think, it's called superpixel image segmentation. It clusters the pixels by the spatial proximity and pixel value. And then after where we have these objects, we analyze basically the distribution of the pixels in each object, and then we define land use or land cover class. It's just an example that was shown before of different variations of this superpixels algorithm and the result it gives. It's a good library in our language. It's called superpixel image segmentation, and it's basically just one line code that creates this segmentation. Here, for example, it's in natural colors the sentinel image of that is showing east part of Kampala, and here it is after image segmentation. You can see that some roads can be noticed. The densely built residential areas are noticed with, and then we just have the last step to basically take these objects and based on distribution of the pixels to tell it's land use, land cover class, but it probably will be ready by Dubrovnik hackathon results, which is on 11th of June. Yes, and that's it from my side. Thank you for your attention. So I'll be happy to answer your questions.
Thank you so much.
Thank you, Dima. Thank you. Very nice presentation.
Yes.
So are there any questions, Jurek?
I have a question.
Sure.
What did you use to train your automated land use, land cover algorithm?
It is automatic algorithm. It doesn't need anything to be trained. It just decides. It just clusters the pixels based on the similarity of the value and proximity. So it doesn't need any training data. But for when we analyze distribution of pixels within object, we will need something to train our data, or we will need to use some known property of different land use, land cover class. But it will be in the next step.
Good. Thanks.
Okay. Sushit, I saw Lydia's probably coming back here soon again. How about you, Sushit? You have a question for
Yeah, just an observation. First of all, thank you very much, Dmitri. It's very interesting work, and I think very important work as well, because land cover classification, is one of the very fundamental kind of important topics that we need in agriculture. So my kind of observation is, for next steps, are you linking with any collaborators in Africa for the capacity development aspects? Do you have any thoughts on that, or any plans for?
Well, I need to discuss it with the members of my team. It looks that, for example, Mamadou from Central African Republic, that he is quite active, and he has published before some articles about this problematic. So this will be next step. We will see.
Great. Okay. Thank you very much.
Thank you, Dima. And we will welcome then.
Okay, so have a nice day, everyone.
Yep.
Yeah, have a nice day.
You too, Dima. Thank you.
Bye-bye.
So we are inviting then Winnie, Kamau, who will then we will do a two-part presentation of the next challenge. It's Winnie, Kamau first, and then Maxillian Houl, I think. Yeah.
Sorry for the pronunciation.
Yes. But so Winnie is joining the room, and I hope that Lilja is not having. Winnie, Kamau. Oops, the back. Then we will do a two-part presentation of the next challenge. It's Winnie, Kamau first, and then Maxillian Houl, I think. Yeah.
Sorry for the pronunciation.
So Winnie is joining the room, and I hope that Lilja is having Winnie. Oops, the fact is do. Okay, Winnie, are you
unexpected?
Are you able, Winnie, to share your screen and start the presentation?
I was hoping Max would be able to do that. Just 1 second. In 1 second.
Yes, because
and Bente, you should probably kick me off. Kick me out of this room.
Yes, I can kick you out of the room. Yes, I can do that. So that's room for Max and Lilja coming back. Okay, we will see you soon.
Okay.
Okay, Max. Yes. So Winnie, now we have. I sent an invitation to Max as well, so he should be here shortly. And I don't know what happens with the Lilja. So it's probably some internet connection. That's often the case.
Yeah.
See.
Okay,
Max.
Yay,
Yes.
Max.
Hello, everybody.
Hi.
Can you hear me?
Hi.
Excellent.
Max, you can share your screen.
Yes.
You can start.
Oh.
Yeah. And then we all turn off our cameras while you are sharing, Max. And then
Can you see it?
Yes.
Okay, perfect.
So I can start?
Yes, go ahead.
So my name is Winnie Kamau, and I'm based in Kenya, and I'm a data journalist and also an open data advocate for Africa. So I push for open data. And our team we were focusing on the desert locust and specifically looking at mapping and forecasting the desert locust. And as we all know that there's a new plague that has hit the eastern part of Africa and also part of Asia, Southeast Asia was, something that's happening. So, and our team is composed of Ambrose Kamya from Uganda, I believe, and Paul Kasoma also, and Maximilian and I. So we know that there's a global pandemic that has taken over the world right now, and we are all fighting an unseen enemy, but also in East Africa and the Horn of Africa, we're also fighting an enemy that we can see. And according to the UN agency FAO, there's the desert locusts. They are really dangerous, and with the increase, right now we are looking at the second generation, the second breeding, and which is more lethal, the experts say, than what we have. So we need to focus on, we were looking at this challenge and we want to look at it from a different perspective. And the perspective we were using is use of satellite imagery and other observations so that we can be able to predict the risks and we can be able to map out where they're coming from and where they're going, looking at the vegetation. So basically that's what we are looking at as a team. And I guess next slide, please.
Yes.
Max.
So yeah. So our approach was separated in two parts. So first, as Winnie said, one for estimating the desert locust impact as response part of the crisis, and secondly, estimating the desert locust location as more a preventive part of the crisis. Both parts are following the idea of technical innovation, so to show the capabilities of remote sensing in this crisis, but also understandable results, because we are talking to users that are not necessarily technical. We are talking to farmers, government, NGOs, and etc. So the first approach, what we can do is we can give precise information of the impact by using high resolution open source data as Sentinel-2 NDVI. So NDVI is the vegetation index. So what you can see on this image, it's close to Mandera in Kenya. It's the intensity of vegetation over the region. So the green part is corresponding to high vegetation, and red part in the contrary is corresponding to low vegetation. And what we can see is the evolution in 1 month between 2019 of December of 2019 and January of 2020, the evolution of the vegetation. So what you can see is like in 10 days, in 1 month, the high decrease of the vegetation. And this is a region corresponding to impact of locusts based on reports of the FAO. So what we wanted to do is that we know we already have this, but we wanted to add some technical challenge to that by using Sentinel-1 data, which is SAR data, radar data. And what we can see first is that there is a correlation between both data, NDVI and Sentinel-1. So on the left, NDVI from Sentinel-2, and on the right, the same region, but it's a RGB image with polarization VV and VH, but also the ratio between VH and VV. So why Sentinel-1? I think the biggest argument is to avoid cloud cover. By avoiding cloud cover, we increase the temporal resolution. Then the idea was to combine this into machine learning or artificial intelligence to train the machine to compute something similar to NDVI, but with the measurement of Sentinel-1. So here's the workflow. So first we need to collect the data. Sentinel-1 and Sentinel-2, both are open source, so easy to collect. Then moving to a pre-processing part, especially for Sentinel-1, where the pre-processing steps are multiple and are needed to be able to use the data. And then moving to machine learning, we used UNet, which is a famous deep learning model for image segmentation. And with this result of what I call S1 NDVI, creating impact mapping and temporal analysis, as I showed with the Sentinel-2 NDVI. So the second part was looking for the desert locust location. So we know that there is correlation between locust location and environmental meteorological factor as vegetation, temperature, precipitation, but also others like some moisture, wind, and etc. So based on this idea, we were thinking about looking for a correlation between those factors, maybe with PCA results. With this positive correlation, making ranking of data, knowing which data can be the most useful to understand where the locust can be or where is the habitat of the locust, and creating binary maps. And then from that, making risk mapping. So for all users with location maps, or maybe in a future step, forecasting maps that will be traduced by heat maps. So basically it corresponds to a species distribution modeling. So we are taking the occurrence of the locust, combining with diverse data from remote sensing and creating heat maps to estimate areas where the need is where there is a need. So that's it for the workflow. For the recommendation, so we didn't finalize both models because it takes a lot of time and there is a lot of parameters to move or to change. So what our recommendation first would be able to create a concrete output of both models. Then we wanted to share the knowledge of remote sensing by making mapping with easy understanding, and also making some kind of storytelling about technology and how satellite imagery can be a solution to fight the desert locust. Desert locust is an actual problem and it's recurring, and there is a part of our group that are motivated to keep working on that after the hackathon. So this is really interesting and encouraging for us. And we had also we wanted to add also maybe another approach, but in future step with the COVID-19 crisis, maybe a combination of data for the risk mapping to ensure that measures that we'll take for one crisis will not aggravate the other one. And I think that can be a good future work. And I would like to thank our mentors, Paul, Lillian, and Kisito, for their support, and of course the team that work together on this challenge. And thank you all for your attention.
Thank you so much, Max and Winnie. Hanka is reminding me that we have very little time, so we'll do very, very quick. Thank you for like this. And I will give the floor for quick questions from the jury, and then Michael will be ready to join us after those questions. Yes, Ian.
More comment. I really like the two-pronged approach. I think particularly the preventive measures, the targeting is really critical, especially in times of the pandemic, to get to really target closely the problem with labor movement and inputs and so on being more challenging right now. As far as the SAR work, very, very good. If you do get a chance down the road, you've probably already thought of this, but you might want to consider looking at LAI and biomass change with SAR. And I don't know if you have
Yeah, I think it can be a good consideration of other type of index. I think NDVI was the most easier because it's easier to compute it and it's easier to get it. But of course, probably other index can be maybe more useful for this task, especially for Sentinel-1, because Sentinel-1 is sending a signal on Earth, and is what is the output of it will be more about the volume of what is on the ground. And probably LAI or biomass will be more useful to make an understandable index, vegetation index of Sentinel-1.
Yes. Lydia, Sushit, do you have some quick questions?
Yeah, just go ahead, Lydia.
I think she's muted.
You're muted.
Sorry. Thank you for your presentation. Yeah. Of course, we are talking about desert locusts now because of the recent attack in very many areas. I'm just curious to know which other solutions can your defined technology address? Have you thought of any, or we are restricting it to desert locusts?
No. Actually, it's not only desert locusts, because we were looking for evolution of the vegetation, so it can be applied to anything. And actually, that's why this technical challenge was really interesting, because it was applied to a specific thing, which is desert locust. We know there is an impact on vegetation, and so maybe by creating S1 and DVI, we can apply to other things. As I said, it permits to avoid the clouds, so if it can be applied to anything. And the example I showed with S2 and DVI with the decrease of vegetation, it's in some point it can be due to locust, let's say, destruction, but it can also be like agriculture a bit, and the fact that agriculture are doing their job, let's say. So it can be applied to something else.
Yeah. Sushit?
Yeah, thank you for this excellent work. I found it really, how you were able to bring this team together in a short time to make this project possible. So congratulations to you and all your team for that. Just an observation. So you're planning to, from your presentation, you mentioned that you're planning to continue the work after the hackathon time as well, right?
Yes, actually on my side, I'm really interested in radar imagery, and and also about this desert locust problem. And I think it can be really interesting to continue on it, as there is things to do. And as I said, it's something that is recurring. So, I mean, anyway, the work will continue.
Okay. All right. Thank you.
Excellent. So thank you so much.
Thank you.
We move on. We excuse you by throwing you out of this webinar.
No problem.
Bye-bye.
Bye.
And I can say that we will have Hanka back in here. And Michael, yes, Mike is next, and he will talk about and present the results of the Internet of Things technologies for Africa. Yes, and Hanka. Okay, well. And Mike is joining us. Mike, are you there?
Yes, hello.
Yes, hi, welcome. So I think in the interest of time, we just jump right on your presentation of the results.
Okay, thank you. I hope you see my screen and presentation.
Yes.
Yeah, okay. So I would like to shortly introduce results and progress in team number 5, IoT Technologies for Africa. Together with the team, we were working on improvement of our sensor solution. It's called SensLog. It's web-based and cloud-based data management application for storing, managing, and publishing sensor data of various forms and various origin. We are using it as integration point for measured and collected data. It is communicating over API and REST services on both sides for data producers as well as for data consumers. Inside is relation database management systems using spatial extensions. So we are able to store data from moving or mobile sensors as well. And we are working with several analytical services. In this scheme, you can see a very simple overview of structure of the new version of SensLog. So it's divided in several modules and services that provide scalability of this solution. So that was one part of this testing of this solution during the hackathon. So we were testing deployment of SensLog on big cloud and how to scale different pieces and microservices to really test, let's say, latency and performance. So we were storing about 20 million of data pieces and store and as observations and observe values. On one hand, we are using our proprietary API over REST services, but to improve the scalability and interoperability of the solution, we are using so-called connector component. So this connector is able to transform different APIs or different endpoints to SensLog API and vice versa. So we are able to offer, let's say, customer demand or use case demand APIs and we try to implement different versions of these connectors to prepare, let's say, template for connecting to SensLog. And second step of this hackathon was to design a connector based on OGC standard, concretely Sensor Things API. So we were mapping Sensor Things data model and REST services on SensLog data model and SensLog API to provide fully compatible connection over standardized endpoint. So this work is still in progress, and I hope it will be solved or finished during continuing related debugging hackathon. So I suppose in 1 month we will have better results. As a third point, we were trying to design a VGI module for SensLog, how to store VGI observation, even they are produced by web application or mobile application. The tricky thing is that VGI can contain not only simple primitive data types, but is possible to store multimedia files as well. So that was necessary to select correct data type for this heterogeneous observations. So we were testing JSON data type directly implemented in Postgres. So in the bottom of the slide, you can see our design of tables and structure of these tables that will be implemented in SensLog data model as one of profile. So that was shortly our contribution. Thank you for your attention, and if you will have questions, I would be happy to answer.
Thank you, Michael. Thank you so much for joining us. The jury, do you have any questions to Michael? No.
Can I? Yeah, Michael, because you mentioned the voluntary geographic information. So in your current, the work you did, did you look into linking with any VGI group activities in Africa, for example?
I'm sorry, but from Africa, we were not contacted by any group, or we we were not in time. From Dubrovnik Hackathon, we are in contact with project We Observe, this European project.
Okay.
We are cooperating with them. You're welcome.
Yeah. Thank you, Michael. Thank you so much. Hanka, do you want to comment something?
No. Just go
on. So the next one up is bye Michael. Sorry.
Bye.
So I see that Akan is here. Akan, you need to raise your hand so that I can invite you into the room. And if it doesn't work, we will have a backup. We have Tuula, yes. So just while Akan is letting us know that he's there, I have to admit I did a bad thing. I forgot to introduce properly the jury members. You heard their name and the very short story, but I think that we can use this time now to let the eminent jury introduce themselves. And we start with our host country, Uganda. So Lilja, let us hear a little bit about you.
Lady first.
Yeah, thank you, Bente. I am Lilja Mazi Kayondo. I am a senior lecturer in the University of Makerere, and currently I head the Department of Geomatics and Land Management, and also act as director for the GIS Center. Yeah, that is basically about me.
Yes, very exciting.
Thank you.
Thank you for joining us and doing this jury duty. And I see that Akan is on his way, but not yet here. So I think that we can go to you, Ian.
Okay, I'm Ian Jarvis. I'm the Director for GeoGlam of the Geosecretariat. GeoGlam is a global agricultural monitoring initiative. Previously, I was with Agriculture and Agri-Food Canada as Director of basically they're monitoring their geomatics and Earth observation systems.
Yeah, so a long time in the field.
I'm not that. Come on.
No, I mean, very short. It's amazing what you have acquired on such short time. That's what I meant. Okay, Sushit, how about you?
Hello, everyone. My name is Sushit Anand. I'm originally from India. I work as the Chief Scientist for the Global Open Data for Agriculture and Nutrition. So my background is in GIS, the Geography of Information System, and I'm a volunteer for open education for a long time because I am very interested in capacity development. So I'm very happy to be part of, in a small part in this hackathon team because I found it very, I was learning so much from the presentations and the work that you all have done, and I'm very grateful to be part of this. Thank you very much.
Yes, thank you.
It's our pleasure, Sushit. Thank you.
Yes, absolutely. And I am afraid that Akan looks to have some trouble. And in view of time, I think we will need to have Tuula come to the rescue. So Tuula, I hope you are listening, and you can ask for the floor, ask to join, raise your hand. Yes, here she comes. So let us see. And then if Tuula, normally she will be quick. Otherwise, so Hannah and I will also introduce ourselves a little bit more than we've done so far. But the jury was the most important for you to get to know. Tuula has used this tool before. She has been a mentor, one of several mentors in the SmartAfriHub. And she has been working on this project across several hackathons. You have already heard that. We are starting work in one hackathon, and then we are continuing to develop it in the hackathons. And here is Tuula. Tuula, yes, you can turn on your camera and your microphone. We hear you now.
Yes, I know you hear me. I'm trying. I'm here and I'm here. Okay. Hello, everybody.
Hello. Yes. So you are a backup helping Akan do the presentation. Do you have his presentation? I think we have sent around a different version of it.
Yes, and I have my own, of course. Yeah. So I will start. I think.
Yes. Go ahead.
Perfect. Go ahead, Tuula. Thank you.
I think I have to do this, and then I should. Is it okay if I just start the video?
Yeah. Oh, you had the video. Okay.
No, this is not the video. Sorry. Slide set only.
Yes.
Okay. So we are going to talk about Challenge 2. And the name of the Challenge 2 is SmartAfriHub.
You are not sharing yet. You're not sharing yet.
No, am I? Where is the button to share? Sorry.
Beside the microphone button.
Yes. Being a backup is a challenging role.
Oh, you do it.
Yeah. Do you see it now?
Yes, absolutely.
Thank you. So, Challenge 2, SmartAfriHub. And the SmartAfriHub should be a very clear concept or platform for everybody now. It's a platform, it's a hub, and it's supposed to bring together the practitioners of agriculture, developers, ICT guys, researchers, everybody who is interested in agriculture in Africa and beyond. So it's a link which merges these different kind of expertise together in one place, in one platform, in one hub. And the challenge was to make it happen. And for us, it means that we had several goals. They are not sort of technical goals or technical aims as we have heard so far from the challenges. It's a little bit softer. We wanted to build a community of practice around agriculture and digital issues. We want to bring together the experts. We also wanted to improve SmartAfriHub as a platform, as a technical platform, to add more features, more applications, more tools, more content. The fourth goal was to improve awareness of these all cool resources of SmartAfriHub. We have to disseminate, we have to communicate, and we have to tell to Africa and to whole world, which is technically possible, that we have this kind of great tool here now. So we have these goals to multiply the subscribers amount and the number of visits in SmartAfriHub. Really exciting goals we had. To make this happen, we decided to create a community of our own, and we did it in WhatsApp. Because of the technical problems, it was a very good solution, because WhatsApp works very well in Africa society, and we could, in that way, we could gather a group of people, nearly 40 guys, and we started to talk. And very beginning, we heard these three basic questions, and this was something we had reason to talk. These gave the reason us to discuss, share ideas, learn from each other, build capacity to each other. The number and number of people and the but quality of expertise is very huge in this WhatsApp group. They really know what they are talking about, and our talk was very practical, very grassroots level talk. But very beginning also, we realized that there is something missing. We have these great questions, but we don't get answers without data. And actually, this was the main point for our hackathon, for our journey. We tried desperately to find right kind of data that we could make new insights, new answers to the critical questions. And because we have so great people in our group, we got data. Actually, we got in the end so much data that we couldn't decide how to deal with that. And we didn't have very much time to play with the data. Anyways, I think that we achieved something. And it's more important than technical solutions or technical new innovations. I think we succeeded to plant a seed of curiosity to work together. We succeeded to share experience, knowledge. We succeeded to make a network which hopefully will continue beyond this hackathon. We got ideas. I learned a lot. And I'm sure that everybody has learned a lot from African agriculture, but also about technology, about data, about challenges. About SmartAfriHub development, yes, it happened. There are now more tools, there are now more applications, and that is because the other challenges made a very good job. They created something new. So at this point, we have new tools, new applications, we have data, and we have a team. It's a very solid basement to do something really cool for African agriculture. And I know these guys, which are in this WhatsApp group, they are ready to do a big change, a big leap. Thank you.
Thank you so much, Tuula. And we will clap for the SmartAfriHub as well. We go directly to the questions, the jury members. Sujit.
Yeah, thank you very much, Tuula. Very interesting. Thank you for sharing these experiences. I think one of the key things about the hackathon, it's kind of an ideathon as well. So your work is and the experiences of this team. I found it very useful to learn from the experience, especially the fundamental questions that that came. And I think that's the main thing. And irrespective of all these different challenges, and in future as well, I think those fundamental questions are what makes all of us work on these areas. So thank you for sharing those.
Excellent. Lydia, Ian, you're fine? Yep. Both muted and both speaking. So
okay.
Ladies first.
I share similar sentiments with Shusti. Sorry if I can't pronounce the name. When I was reading through the report, exactly that was my comment. And I think the presenter tried to also put it across that there is nothing you can really pick out directly from what has been done, but the experiences and whatever has been accumulated is quite massive and it's appreciated. Thank you for the participation.
Thank you. Ian, your turn.
My comment is the same. I think the tangible results are not huge, but the community building is there. And I really like the way this initiative reached out to some of the other challenges and tried to integrate some of that. Yes. And it could be the start of something great.
Excellent.
Thank you.
Thank you so much, Tuula. Thank you so much, Akan. I know you have been preparing also. So we will go to the next point on the agenda, which is a little bit of a break. We are, according to my calculations, about 19 minutes behind the schedule. Not too bad. It could have been worse.
I suggest 5-minute break instead of 10.
Yes. So I suggest actually that we do the break for 4 minutes. Once I start the video, that will entertain you somewhat. The video will last 4 minutes and 41 seconds, I think it was. So we come back after the video has ended. That's when we start again. So 4:41 from when the video starts. Thank you so much so far, and see you shortly. Take a quick break and then come and watch the surprise at the end of this video. Let's see if I can share the video. Yep, here we go. And we are back. I hope you were able to enjoy the dancing gray-crowned crane, which is, I believe you call it the national bird in Uganda. It's a bird on your flag.
That is true.
Yeah.
That is true, Bente.
Yeah, it's a wonderful bird. I fell immediately in love with that animal. We are going to go further. The video, by the way, if you didn't catch it, because if you actually took a serious break, we will post the link to this video in the chat, so you can enjoy it very quickly. If not, you will be able to enjoy also it in the replay, which all of you who are registered will get in your inbox. So I think we are ready for the next one, which is that. Who is that? That's Karel, as far as I can tell.
Do we have Karel here?
Maybe I should go away.
Yes,
Yes.
I will.
Yes.
Thank you. Thank you.
Thank you very much for being here, Tuula. Bye-bye.
So let's see if I have Karel is here. Yes, he is. So I invite Karel in, and there's a room on the stage for Karel. So we are going to talk about the EU for EU for food security, actually. So it's Earth observation for food security. It's a big topic. And Karel is joining us. I think Karel will stay with us for the next one as well, if I'm not mistaken. Yes.
Oh, nice.
Hello, Karel. Hello.
So I would like say that you organize good meeting and a good job. I am watching this from the beginning, so very nice.
We are happy to have you.
Thank you.
Yes, thank you. And we are excited about the results.
So we could probably disappear. And Karel, the floor is yours.
Okay, I will switch off.
Not the sound, Karel. We need your sound.
Sorry, something was frozen.
Oh, okay. So we will. Ah, here you come. Yeah. And you click on the hide button.
Yeah.
And you yeah.
Yeah. Okay. Do you see my screen? Yes.
Yes.
I would like at the beginning, thanks to Dmitri and Tuula, because they in some way presented already part of our result. Because presentation, but all presentation will be the team who in reality done technical support for other teams. But as I'm working long time with ICT, I know that on the first place are people. So Tuula done a lot, and also about the data, and then the data. Yes, the technology without people and without data is about nothing. But now I will speak more about the technology and what we done and how we try to support the teams. So now this challenge was the part of Air for Agri project. This is some European study analyzing potential of Earth observation for agri-food sector. And my task in this project is mainly to look on the possibilities for developing countries. In our challenge, we realized two things. Yes, one was mainly focused on collecting some ideas what could be useful for people from Africa from Earth observation, and second was on some platform for automatic classification. In reality, the first part was related fully with L4 Agri project, and we use questionnaire from L4 Agri, and thanks to Tuula and also thanks to presentation on SmartAfriHub, we received very good response from the people participating on the hackathon. So I can say that now in this review from L4 Agri is coming approximately 50% of response from Africa. I will not show all questionnaire, but I will show you few answers, how they are analyzing, yes, and what are current results, because this will be then the part of some recommendation for European Commission, for ESA, what has to be in the future supported on the level of software, on the level of the technology. Here is, for example, very important, yes, to see that a lot of farms or a lot of response was focused on small farm, and this is something what is giving us for future feedback that we will need to probably look on some better resolution than is current Lancet or current Sentinel 1 and 2, that in many cases we will need to go also to some data which are more precise. And I think that mainly for Africa, it's important if they will be possible to find in the future some financing, how to do. This was about the first part. Second was to support processing of images, and in reality we don't done in our task processing, but we agreed with other task that we will deploy strong infrastructure, and this infrastructure will be used for experimentation in other pilots. So you can see here the basic components, and about usage of this many components. Dima made his presentation in the past. So as he already told, it's based on the Jupyter notebook, and in some way it is based on our experiences from other project EUBSDAT. And we also deploy some sets of data, mainly on around Victoria Lake and Victoria waterfalls, and this data was then analyzed by other pilots. We prepare also data. We prepare also data coming from NDVI indexes from this to be possible to make some experimentation. As Dima mentioned, some people from Greece and Africa already start to play with this, and what is our expectation that this part of hub will be open and running for the future, and our idea is to continue with capacity building, because we see this mainly as some support for capacity building and learning people how to deal with this new technology, and relatively with could be zero investment to have chance to make their own tests. So we expected that our work will also continue after end of the project. Some analysis was done by challenge 3. I think that also challenge 1 used partly some data which was prepared here. So this is all about this challenge. I think that it is not time to describe detailed technology, but I think that it is more useful to have feedback and to also hear some result from other challenges.
Oh, thank you so much, Karel. We will have another one from you as well, but before we go there, we would like to hear if the jury has some question for you.
Yeah, I am ready to answer.
Yeah, thank you, Karel. I think one of the things, just an observation. It's really good to see the linkages of not only this presentation but a lot of with the other hackathon teams, and I think that's really one of the kind of positive messages that I learned was to make sure see all these cross linkages of all the different work and activities of all these teams. So that helps us in future for these teams to continue in their ideas in one form or the other. So thank you for that.
Okay, thanks. Some other question?
No, you're good. Jury is good. Yes. So then
go ahead for another presentation.
Okay. Okay. Let me seconds to select other presentation. Seems that it will be this.
Yes, and
okay.
Lydia, your camera is still on.
Okay, do you see?
Yes, we see it.
My second presentation, it was about the challenge text mining and metadata. I have at the beginning said that we succeed only with the half of this challenge because we tested some technology from text mining, but the result was not satisfactory till now. So this main things was focus on again not data but metadata, because Tuula mentioned data, but to be able to discover data, work with data is important to use metadata, and this our challenge also work very closely with challenge 9, which will be presented later. And all what we done was fully integrated into SmartAfriHub, yes, because the goal was again to support SmartAfriHub. Bente told that they discovered a lot of data, so now will be the work to in some way put this data into the metadata system and make this available, and also then offer to the people some tools which will help with easy usage. So what we didn't reach, the goal was also to use technology for text mining and make crawling of the different web pages in Africa and recognize there some addresses of OGC services like WMS, WFS, and other. The partners who start to work succeed to crawl this many web pages from Africa, but then due to COVID-19, they start work with other problems, and this part was not solved. I will now show you this architecture. You will see this architecture one more time in my last presentation. And in this presentation, we were mainly focused on these things related with this Open MITSCA and MITSCA-like, because this is the tool which is able to manage geospatial and not only geospatial metadata, and is able to serve this metadata in the form also of link open data, because Open MITSCA is one from the first catalog who start work with implementation of OGC standard GeoDCAT IP, so Open MITSCA is able also to support this GeoDCAT IP, and here is integrated with a number of components, and the big part of the focus was on the integration among these components. Here you can see what are the components of MITSCA, and what is important with MITSCA, we are able to harvest different type of metadata which are based on OGC standard, and to put this metadata on one place and to support visualization. What is there additional according to the standard of OGC? And I will speak much more about this in the last presentation, is that we are also working with map composition. And this map composition is something what could make easy work of the people who are not specialists with the maps. Yes, it is not, you are not working or not searching for number of, could be WMS or WFS or other services, but you are searching for the maps which are composed from the services and which are prepared already by experts. So this is something what is additional according to the normal standards. And what was important was to integrate it, this catalog with visualization client, because for people it's important that they are able to work directly from the client with the maps, and they don't need to switch among two applications. So you are all accessibility able to do with the simple client. And then you can easily this data display and work with them. Other things is on this theme is this MITSCA Lite, and this is some tool which could be some part for, could be some citizen science publishing of the maps. For example, you will discover WMS anywhere, and putting this URL of this WMS into this harvester, MITSCA is automatically reading data from this WMS and publishing metadata. So, okay, these metadata are not so good like if you will do this regularly, but you are receiving the basic information about the data, and you are making this metadata available for different users. And as you can see, you can work with different format. Also, you can use WFS. You can use feature catalog. So you have different possibilities how you can easily put some services available for other people. Okay, this is all for the second presentation.
Thank you. Thank you so much again, Karel. I will do the clapping.
Thank you very much, Karel. Thank you.
Yes. Okay, so questions from the jury.
Do we have any?
No, it's all.
No questions? Yeah?
Yeah.
I have a remark. I am passionate about metadata. Any efforts to address that challenge of metadata, especially in our environment in Uganda, much of our spatial data is not being utilized because of, no knowledge about what it is, how it came about. So I just want to appreciate Karel's presentation. and give him a thumbs up for attacking metadata as a challenge. Yeah.
It is for me very interesting because on one OGC meeting, it was, I think, in Orleans, yes, we discussed if metadata are boring or not, yes, and we had now a nice discussion about this, and I am happy if I hear that some people are really interested about metadata.
Yes, yes, metadata has its fan club, even though there are some haters. Okay, Karel, thank you so much. We will see you later. But
okay, how I can leave this?
I will throw you out.
Okay, good. So it's easy for me.
See you, Karel. See you.
You'll come back again. So now we are waiting for Foteini, but I don't see any request. Foteini, can you please raise your hand so we can invite you in here? We are going to learn about legal and ethical aspects of data, and here is Foteini asking for it to speak, and she's invited. While Foteini is coming in here, maybe you should say a few words about yourself, Hannah.
So hello everyone, I'm Hannah Kubíčková. I'm employed at Plan for All Association as project management support, and also I conduct a research dedicated to Earth observation and deep learning. We are trying to detect some objects on satellite data. And also, I am the one who is involved in hackathons planning. So I am the one who was constantly spamming your email box with some information. So this is me.
Yes, this is the famous Hannah.
And Bente,
yes,
you should also introduce yourself.
Yes, I will. But right now, I am looking at. Looks like Foteini has some trouble getting in here, because I invite her and she's being probably rejected. She's asking again for the floor. So there is something there. We have tested with Foteini before, so the tool should be possible for her to use. Do we have a backup for Foteini, Hanka? Do you know?
No, I don't think so. But we could probably switch Karel's and Foteini's presentation.
Yes.
Because the Karel is the next one who is coming after Foteini.
Yes.
So Karel, are you able to join us again?
Well, he has to ask for the floor. Yes, he's humbly asking for the floor. So let's see. And now, I don't know what to do with Foteini here. Maybe she will be borrowing. Yeah, we'll see.
Yeah, Foteini has some connection issues.
Yes.
Okay.
She's writing to me.
Welcome back, Karel.
Hi, Karel.
I promise that it is last challenge which I will present today. So.
Yes, we are happy to have you in the room. So let's hear about the maps. I think it's mapping that you're going to talk about. So let's see.
Okay.
And the hide button.
Yeah.
Thank you.
See my presentation?
Yes.
Okay. This is a challenge which is part of both hackathons. Yes, Kampala and also Dubrovnik hackathon, and there is the work of more people. Big part was done by Runar from Norway, Raitis from Latvia. So this is really the teamwork, and on the end the result is till now not full, but the big part of the result is available already on this Foodie SmartAfriHub. What is the problem? Yes, we have a big amount of the data from Copernicus. Data are really collected massively, and what is important is how people can easily work with this data, or eventually as citizen scientists can contribute to the work of this data. So we are sharing the data, but the normal people don't need data. Yes, they need to have some results. It could be some analysis, or it could be some maps. And what we are trying is to move from this could be data sharing approach to more map sharing approach, because I think that this is very important. Generally, such effort was some years ago in OGC, where was introduced the web map context. So we start already some years ago with web map context, but this web map context was limiting. And what I would like now a little express is this map composition concept, and how it could be used, and also what we done here for this hackathon, and what is now under the development, and where is first prototype, which I hope will be soon also implemented as a part of SmartAfriHub infrastructure. So map composition is some JSON-based interchange data model, which describe some map services or local maps which you are putting together, and we are sharing not only these poor services, but we are able to share also this JSON description. In reality, every of this JSON we are describing also by metadata, so we can make this discoverable from the metadata system, and people are able to change this map composition between them, or eventually there is also support to share this map composition through social media like Twitter and Facebook. Yeah, so it is based on the integration of the data, and then preparing visualization. As I already mentioned, important is that experts are able to prepare thematic maps, and these maps can be used by other people. But what we are also now focusing, that people can make this map composition allowed, or can put their own data as part of map composition. And this is what we see as important, that anybody will be able to collect their data and share this together with others. So we see this as a big potential for citizen science, and also good potential for collaboration, because you will be expert, you will prepare the data for farmer, and farmer can then work with the data. We had two sub challenges, yes, and one was on real practical testing of the map composition, not only as a part of the portal, because this is something what is now integrated in AHLayers NG, but we also try to connect this with other systems, and this is mainly QGIS. So we develop some plugins to QGIS, and QGIS is now able to connect this SmartAfriHub, and on one side see the map composition which are available on this SmartAfriHub in QGIS, but you can draw your own layers and share this with the people, putting this back to the portal. So QGIS now is something like some client for the portal, and is able to work with this. This is very important, that we demonstrate that different open sources are able work together and share the data, is that it is not necessary to do such work only in some one could be expensive commercial software, but that you are able to communicate among more the systems. So again, here is the scheme which you see, and this part focus on the map composition is this external application QGIS, ageless NG, which is the client, and this client also support publishing data directly. Lyman is some other extension of for GeoServer, allowing to publish directly data and metadata from different systems, and metadata are then again stored in OpenMitSCA. So if you would like to prepare some your map composition, you have to join this Lyman and compose your maps from different sources which you have available, and thanks to Tuula and their team, we start to prepare the sets of the data, and now the next work is to make more this map composition for different purposes very easy, and to distribute this data and use this data. So you can see that they were already prepared on the base of the data which received this Tuula challenge for different countries. And here you can see also the communication of this portal with QGIS. And there is second part, which is done mainly by Runar, and I think that it is something really very challenging. There is first prototype, not till now integrated with the portal, but I hope that we will succeed, and we will continue during the Dubrovnik. And this is something what you know. If you are writing the text, you are using Google Docs, and you can share the text and edit text from different places in one moment. And we start to work on such concept for maps. So you can have 2 or 3 or more people. Everybody has some whiteboard client, and due to this infrastructure, you are able to edit parallelly data from different places. I think that this is something what could be now very useful in this COVID period where you are not able to sit together, but also for planners, if you would like to explain to the people something, you can draw these maps and other people will receive these maps. So we see this as some real good future for citizen science work, for scientific work, to be able to share these maps. Okay. So this is really all from my side.
Thank you, Karel, again. So the jury, do you have any questions for this presentation that Karel gave?
Yes,
Kozhuch?
Yeah, thank you, Karel. I think, in a way, the citizen science aspect you raised, in fact, the previous presentation on the metadata, when I now when I get the full picture, it's really one of the amazing stuff I could see as a potential for the wider community as well, because you have citizen science is a huge contributor for data, and it's going to increase in the future as well. So if you're able to capture the metadata and all these linkages, I find it very fascinating to learn all these aspects as well. Thank you.
Thank you. This is, it was not possible to cover by one challenge, but we tried to put a challenge together, and really we were also happy that we receive some feedback and data from the work of the Tuula, because it was also important for us, yes, because if we will not be able to build community around, we will never succeed with any system. Yes, this is really the most difficult, and I hope that with Godan we will be able to continue on promotion of this aspect, and we are ready to cooperate with any parties to make data much better available for people.
Thank you. Thank you.
Other jury members? No, you're good. So just a point to this work when we were mentioning citizen science, that in the Dubrovnik INSPIRE hackathon, we are also working on making the citizen science data available. So there's I think it's great to see that there are different initiatives going in that direction, because, as you said, Sushit, it's a great potential of in situ data in particular.
I think that we try to use a little different approach, yes, than is normally used in citizen science, because normally citizen science, most of things is that you are collecting some data with smartphones in the terrain, sending to some repository. So we are trying a little change or extended this approach, yes, to be able to do some additional things.
Yeah. Okay. Now
let's go back to Foteini's connection issue.
So you will again put me out, yes?
Yes.
Can you try to leave voluntarily also? See if that helps. Karel, if you try to, I don't know if you can turn off some.
How I can turn?
Is there any button?
No.
Something like leave?
No, I don't see.
Okay, so Bente, you have to kick him off.
I just did. Brutally. So
thank you very much, Karel, again. Thank you.
So I saw the hand of Foteini here just while Karel was speaking, and now the hand has disappeared. There she is. Let's see. I captured her hand. And there are sometimes, as you probably all know, when you are dealing with technology, there are some DLLs or what have you that is acting in mysterious ways. So we have to deal with. Foteini. Yeah. So Foteini, we are seeing you very soon, I guess. You are in the room. So turn on your camera and your microphone.
Yeah. Can you hear me?
Yeah, you can hear
okay,
me.
Perfect. And finally, I have an issue with my camera, though.
Yeah, never mind.
Okay.
Hello,
everyone.
You'll manage it.
Yes. Sorry for that.
Okay.
I had some issues with the technology here. I'm very, very happy to be with you all. You are doing an extra work. I've watched all the presentations from the previous teams and the mentors. So I will now speak about my team, Challenge 9, on ethical and legal aspects of open data affecting farmers. So let me see about my presentation here, if I'm able to share it with you. Just a moment.
Remember to click on the button on beside the microphone on the webinar.
Yeah, I did that, but I need to be sure if you're able now to see it. Do you see it?
Not yet.
Okay.
I think you can click on share all screen, and then when you are sharing all.
I have an issue again. Okay, let me do that now.
Yes.
Yes.
And then you find your presentation somewhere on your.
Oh gosh. Sorry for that again. Doesn't really respond. Nope.
You don't get in touch with your. Well, that's not the presentation.
No,
if you have you're clicking to the right. That's the presentation. It looks like you have a PPT there.
Yeah, but it doesn't really respond. No. Let me see this one. Now I think it's okay.
No, further down. I think you need to go. Yeah, there.
Here.
Yep. Yes.
Do you see it?
Yes.
Oh,
so,
good.
So go in a go
here
into a presentation. Yes. Wonderful.
Yeah, okay.
Perfect.
Okay. Sorry for that. Oh, okay. So, as mentioned, I'm going to talk about.
You clicked out. You ended the presentation now, so you need to start.
Okay. Is it okay?
Okay. Now it's the first one. Yeah.
Finally. So I'm going to discuss about our team, what we did. As you may have seen, our topic is quite different from the other topics. It has to do with the ethical and legal aspects of open data affecting farmers. It's not so. It's not technical at all. So the team goals was to identify gaps and highlight the often complex legal issues related to open data in the areas of law, and that means what about data ownership, who has access and control of data rights, what about the current policies of open data in agriculture, are there any? What are the challenges of not being so many policies? We also talked about the codes of conduct, about issues of data protection, the IP rights, what about privacy, whether farmers are willing to share their data or not, because there are some fears around their personal data. There are some fears about if they get benefits back. So we focused more not on the challenges, but basically we focused more on the benefits and value of data sharing. So with this hackathon and this team, we had the opportunity to discuss and evaluate more, as mentioned, the importance of data sharing in agriculture, what are the potentials and the benefits of data-driven services and information specifically from the farmer's angle. So we just explored some topics around empowerment of farmers, optimization of agricultural practice, stimulation of rural finance, how can we facilitate the agricultural value chain, how can we enforce policies, how can we influence somehow the persons and the stakeholders engaged in the data value chain in an open dialogue to see and estimate more what are the benefits of when we share data. So in order to do that, with the benefits and the value of data sharing, we basically focused around the areas of production, market access, finance and organization. By illustrating some best practices, we asked from the participants to give the team some tangible examples when we talk about benefits of data sharing, what it is about. So we wanted them to share with us some examples from their work, from their every day occupation. And here we gathered some examples, we documented them. And I will just mention some of them. So in the area, let's say, of production, the benefits of data sharing is, for example, when we share data on field side and location, farmers can receive better targeted inputs. That comes from IGTF Uganda that shared with us its input. Or farmers' data on their experience with seeds performance helps the seed companies to improve the quality of seeds, for example, resilience to pests, erratic rainfall, and other shocks. That comes from Lena Wanji. Also, data shared by farmers about the agrochemicals they use help agro-dealers to know what to stock for each season, which means the farmers will access the inputs whenever they require them. So about the conditions, let's say another example is that sharing soil maps as open data allows the development of applications to better advise farmers on which crops to plant based on soil types and other field conditions. Around market access, by farmers sharing data with social enterprises, it is easier to ensure organic certification. Or around traceability, using blockchain smart contracts to ensure traceability, tracking orders from the consumer through the logistics and blockchain to the producers through food hubs and farm hubs. This is another example. Or around prices, identifying the location of farms can be used to attract a premium price. For example, coffee is grown at altitude as a premium product, no cafe in Uganda, for example, or supporting data-driven aggregation at production and order accumulation by household for order aggregation to support trade-related actions. So around finance, basing credit on the basis of farm produced data for delivered farm produced data recorded over a period for short-term credit, and for produced data history recorded over a long-term credit. By sharing location and profiles, it is easier for associations to arrange credit for members and them to use these profiles as collateral for loans. Around insurance, by sharing location information and profiles, farmers can have access to new insurance schemes. This comes from ACONET, Zimbabwe Farmers Union in Zimbabwe, as mentioned. Also, associations using membership profiles of farmers can provide a distribution process for the government in distributing subsidies. Around organization and members organization, farmers associations need farmer data to more effectively organize their associations. An example is from KPED, Burundi, that supports around 30 and more farmers organizations in organizing crop calendars, collective input purchase, and access to markets. So this was the mapping that we managed to do. We wanted to be known more the benefits. Sorry for that. And I think we managed to have a first idea to communicate it more via this hackathon about the benefits and value of data sharing. And another thing that we did, because as mentioned, our topic is quite specific and different than the others, we did a webinar like the other teams as well. And our theme was around how to mobilize capacity development in agriculture for smallholder farmers and how to actually bridge the digital divide, where there we addressed the risks and benefits of open data sharing in agriculture. We also tried to shed light to the ethical approach of open data and what, for example, is responsible data and how can we have a responsible data governance. We also touched upon the impacts of digital technologies on different segments of agri-food value chains. We addressed the issue of digital divide specifically in developing countries. And we tried to do some recommendations and also worked on the capacity building. And finally, we focused on the codes of conduct, around codes of conduct, since we addressed the issue of ethics. And since we don't have any legislation right now that could really there are no regulations around the data flows in agriculture, we thought that it would be good to discuss more about these codes and principles. The rationale of the development of these codes is, as mentioned, to fill the legislative void, set also the common standards for data sharing contracts, and provide fair and transparent governance structures for agricultural data by ensuring mostly farmers have confidence in how their data is collected, used, and shared, because nowadays, as we know, We have the issues of how there is no trust from farmers to share their data, because they don't really get benefits back from the agribusinesses or the agtech providers. So one way of enhancing more trust, transparency, is to develop these codes of conduct. So we tried to draw some conclusions on commonality and differences between the existing codes in agriculture, the Europe Code of Conduct, the USA Privacy Principles, also the New Zealand Farm Data Code, and recently the Australian Code of Conduct. And we wanted more to do, besides the commonalities and differences of these codes of conduct. We wanted to proceed to a more practical way to do some recommendations on a further customizable code of conduct that would best address the needs of the farmer and empower farmers, and include them more into the discussions around codes of conduct and how conduct could be fairer and more transparent. So during the hackathon, we identified the current legal and ethical issues, that we do need an agile ag data normative framework. Our approach, as mentioned, was to provide this basis for the general scalable guidelines for associations, for smallholder farmers in developing countries, on how they can use, adjust, negotiate a farmer-centered farm data sharing code. And we worked with the team and with the participants, and we asked them, based on the work that we have already done on the codes of conduct, and asked feedback from them on how can we develop this code of conduct that best address farmers' need, what should be included in to be farmers more aware. And we have developed an online tool done in collaboration with CTA, and the scope of this online tool is for everyone who wishes to learn about the codes of conduct. Then he or she could build their own code of conduct, and they could select from clauses that we have discussed within the team. We documented these clauses around farmers' rights, who is the owner of the data, rights around data portability. These are the clauses that we mentioned and we worked on, and based on the feedback of the participants from our team, we were able to develop this online tool. So I would say, closing this presentation, that our outcome and result, that the most important one is this consultation around the online tool on codes of conduct. How can we enhance trust? We can enhance trust by developing these codes, by including farmers into the discussions, by knowing their rights, by knowing when they're able to terminate a contract, that they do need to give their consent. So I would say this was the most tangible outcome that we had from our team of Challenge 9. Thank you.
Thank you so much, Foteini. We did it in the end. So.
Yeah, finally.
Thank you so much. Yes, so now we are approaching, well, first of all, quick questions to Foteini while she's in the room.
Do we have any?
Yeah, just to thank you, Foteini. I think because this challenge, I think it's a cross-cutting challenge. It links all the work. And in fact, I was listening to Tuula's presentation on when she raised the fundamental questions, and I think this is also a fundamental question on for example, how does for example, smallholder farmers benefit? All these a fundamental question, and the ethics and these aspects need to be considered fundamentally in any projects that is happening. So I think this challenge is very important, and this helps us refine and more ideas for the future. And I hope you also got a lot of feedbacks from the different participants to help you refine your code of conduct with with inputs from the smallholder farmer communities, which is also very important. Their voices are also heard. Thank you for that.
Thank you.
Thank you. More comments? No. Thank you so much.
Thank you.
Yes. And
Thank you, Foteini.
Yes.
Thank you.
Thank you.
Bye bye.
Bye. Bye.
And we will.
So we are ready for our last presentation.
Yes, Daniel says it's ready. Yeah, there he goes. So I will invite him into the room. We have one more presentation before the jury break, the jury duty, while you can watch some videos, some beautiful footage from Africa, from Uganda in particular. The jury needs to work. So just to give you, we are sort of gradually getting to know Uganda through this hackathon event. Okay, Daniel, he's in the room. And let's see. Hello there.
Hello, everybody.
Hi.
Hello.
So we will disappear.
We will disappear, and we are ready for your presentation, Daniel.
Okay, I'll disappear then as well and try to start my presentation. Okay, can you please confirm that you can see it and also in full screen?
Yes, full screen.
Okay, perfect. So again, hello everybody. My name is Daniel Beran and I am part of the traffic modeler team under the Plan for All Association and also under the University of West Bohemia. And in the following 5 minutes, I'd like to introduce you to traffic modeler and also explain what we have done for the Kampala hackathon and how did we try to use traffic modeler with open source data. So very brief introduction about traffic modeler itself. Traffic modeler is a server-based traffic modeling tool that can be accessed using API and thus resulting in a web browser application that you can actually use to calculate what-if analysis of any traffic model that you import into the application. So far, we've been testing mostly in Pilsen, Czech Republic, which is our hometown where we are. So we are you have the best connections here, and the model that we're using here actually offers the most accurate traffic modeling. But I think that for now, what is enough is what you see at the bottom. So what you can do in the application is that you introduce some scenario. For example, what would happen if you put a stop sign right here, or if you have to do some reconstructions at this street, and how will that influence the rest of the city? So, for example, people have to go around it. Okay, but that is Pilsen. Now, in general, what do you need for traffic modeling? Again, I will try to be really brief here, but you need some basic components for traffic modeling itself. So you need a network. Obviously, you need some geometric representation of the roads themselves, and you need also some network zones, or so-called traffic generators, which you can imagine as city districts that generate some demand for traffic. Then you use those data to calculate so-called origin-destination matrix, and you assign those cars into the network. If you want to get precise modeling, you also need calibrated, which is, of course, very hard to come by using only open source data, so we didn't get this far. But the other steps we did for Kampala. So this is a very brief description of our workflow. You can read about it in more detail in the final report, or maybe you already did. And so what we did, we decided to use OpenStreetMap as a source of the geodata, which is pretty straightforward. But it's not so straightforward if you want to actually use those data for routing, because the OSM, as it is in database, is not routable. So that's why we used OSM2PO, which is an open source tool that you can use to download OpenStreetMap data that are routable. It's not so easy as just having that data and put them into the traffic modeler, because obviously OSM and traffic modeler use different data models. So we had to design a matching table between those two data models. That was sometimes very easy, just renaming different attributes. Sometimes it meant deciding, for example, what how many cars was the capacity of highway, the class highway in OSM for Kampala, what's the capacity of road for a first class, so-called first class classification of road in Kampala, and etc. And sometimes it meant some simple scripting, for example, that in OSM both way of the streets are sometimes represented by only one edge, but for traffic modeler data model, we need them to be split into two, so you can actually have that represented in the map as two different side of the road. We also had to come up with the traffic generator, so we had to find out how many cars actually want to get from point A to point B in Kampala. This is very hard to do without any local knowledge, without any calibration. But we estimated based on how many people actually live in each district, which is a very simple way to do it, but it is a proof of concept. And once we had that, we used Traffic Modeler to calculate the origin destination metrics and deploy the Traffic Modeler application, which I'll show in the next slide. And that is something that we have done for Pilsen and for Flanders and other cities. So I'll now show you the video of the Traffic Modeler application. This is something that is publicly available online. So right now we're looking at the city of Kampala, and I can create a new experiment. I'm calling it a Kampala hack. And now within that experiment, I will create a new event. Again, you can imagine this as a road closure due to some maintenance in that particular street. So I'm zooming in, and I'm going to select both ways at one particular point in the road. I'm going to close it, and now I'm going to save the experiment and update the model. So now what is happening is that the information about what roads did I close are going to the server. The server is calculating how does it influence the traffic in the data model, and now it already sent back the results. So now you can compare it, and you can also compare it using special compare visualization. So right now I'm selecting the two models, the default one and one with the closure, and you can see that the red segments mean that in those particular streets there is now less traffic, and the blue ones, let me put it back, and the blue ones mean that there is fewer traffic. What have you learned? Obviously, not very surprising. We knew that already. Open source data has its limits. So for precise modeling, you need something extra. For example, realistic network attributes. We are struggling with the fact that we can't really guess the capacity of the street just from OpenStreetMap. And we'd also need more dense network of traffic generators. Of course, local knowledge, some local calibration data would also be needed. But the point is that we can do this from open source data. So if the city of Kampala, for example, would update their database in OSM, we could redo the process very easily with more precise input. Thank you. I see that it took me 7 minutes, so 2 more minutes extra for what time I had. But if we have time, I can show a live demo, but it wouldn't be anything else that you saw in the video. So it's really up to you, but thank you for your time. That is all.
Thank you, Daniel, for your excellent presentation. Thank you.
Always fascinating to see this traffic modeling. Do the jury have some questions? No?
Yeah, just a general observation. Go ahead, Lydia.
Yeah, I would like to hear from the presenter. Of course, I start by thanking him and appreciating for contributing to the issue of traffic in Kampala. I know it is a menace. Your usage of population data, I would like to hear that you narrowed it down to a certain class of population. Not population as population, maybe you eliminated age groups and that kind of thing.
Yeah. There is a good idea. We didn't have. We actually took some time to design a better workflow that could be applied for the assessing of car trips per traffic generator. We didn't get to implement it, so we really used only raw population, basically population per district, and then times certain coefficient. So I think that for Kampala we used 0.2, so basically 0.2 cars per person per in peak hour. This is very rough. Ideally, you would create this coefficient more smartly, for example, using the number of hospitals, number of schools, number of offices in that particular district, which would, in theory, and this is something that is being done in Czech Republic. We consulted it with traffic experts here that are collaborating on traffic modeler as well. But it wouldn't really make sense for us to do that for the hackathon, because we would still have to guess, for example, the number of people that go to that particular hospital, mall, office space, or housing facility. So something like this can definitely be done, but local knowledge is required for it to be precise.
Sawa.
Thank you, Daniel. And Sushit?
Oh, thank you, Daniel, for this presentation. And mine is just observation. So it's good to see the links you made with, is it a local university who was helping you? Who was your collaborator?
I'm sorry, I'm not 100%. Maybe Karel should be in chat. Maybe he can help me answering that question. I'm sorry, I'm not 100% sure because I was more on the technical side.
No worries.
I'm not 100% sure.
No worries. I will follow for that. Thank you.
Yes. So, Daniel, do you know if you consider any environmental data or sound or noise kind of data? I know we have been discussing this before, and I think it was an issue that was brought up particularly in this hackathon, but I don't know if you got around to it.
No, sadly no. At this stage, we are really trying to improve the traffic model itself and the output models from it. There's another degree of possible error. That's what it is when you're trying to model some new phenomena from it. So as an output, not really. And if you mean if we did consider it as an input, then, for example, that you could, because weather, for example, has an influence on the traffic volumes, then again, that is possible, but we would first have to solve the more impactful issues in the modeling itself. But later it could come into play, yes.
Excellent. Okay,
Thank you so much.
Yeah.
So we are ready for, thank you, Daniel, for joining us.
Oh, thank you.
See you later.
My pleasure. Okay, I'm logging out now. Thank you.
And we are ready for our jury duty to select the winning teams. And also, we have prepared 2 videos for you. As Bente already mentioned, there will be shown beauties of Uganda, and also some video about Makerere University. And at the end of the break, there will be an interview. I will interview Bente and Karel, the godfather of Inspire Hackathons. So stay tuned.
Yes, and the break, when we are a little bit...
there will be 10 to 15 minute break maximum.
The jury, have you any suggestion for a time when you want to force yourself back into the room. Okay.
I'm good right away.
Yeah. Okay. So 10-minute break is sufficient.
That's fine.
Yeah. So then we say 14. Let's say 14:40 because it's 14:30. Well, 32. Okay. Yeah.
Okay. 14:40.
Yeah. Let's go for that. I think it sounds like you are able to do it, and then the break is shorter, so that will be fine, I think.
Okay. And please mute yourself.
Yeah. So don't
make it
leave,
secret.
yeah, don't leave this room. You will enter the Skype room. The jury will enter a Skype room, but do not leave this room. Just turn off your mic and the camera. Yeah. Okay. And I will start the video. We will start with the natural beauty of Uganda.
Bente, unmute yourself, please.
You're sorry. Now you learn about the Makerere University, or like this. You should be able to see it here. Yes, here we go.
Everyone would want to be exceedingly successful. Education is a foundation to success. One must attend education from an institution that provides transformative and innovative teaching, learning, research, and services responsive to dynamic national, regional, and global needs. The year 1922 laid down a stone mark for this dream of success, the start of a technical school that has grown beyond leaps and bounds into the great Makerere. Makerere University now boasts of a population of over 40,000 students, making her one of the largest universities on the continent. Ranked third as the top prestigious university on the African continent, Makerere provides the best programs that have nurtured many influential and powerful figures impacting the world. Makerere University offers more than 457 programs, awarding certificates, diplomas, undergraduate and postgraduate degrees. The university is renowned for its disciplines that include humanities, social sciences, natural sciences, veterinary medicine, and human medicine, among others. At Makerere, we take in the importance of carrying on your passion to the world. For example, we offer programs in medicine for students who have the passion to treat and save lives. Engineering for those with the zeal to fix and design the world. Law for students whose passion is to fight for rights and justice. Performing arts and film for the creative minds, and many more. Makerere does not stand alone. We have linkages with communities through the internship scheme, with the aim of producing practically oriented graduates that meet the required job-related competences of their future job creation and community relevance. Established in 1949, our library is the biggest on the continent. It is the national legal repository for the country and for the United Nations. It archives rare and near extinct material of historical importance. Makerere University has modern facilities through which it provides a very conducive learning experience. We offer our students practical facilities, including the teaching hospital for medical students at Mulago Hospital, an agricultural research institute at Cavanyolo, and Wiana Farm. At Makerere, we are also very proud of our world-class science labs. Computer labs for the IT students, a radio station for journalism and mass communication students, an art gallery for the students of industrial and fine art, and many more. Students' learning is also enhanced through exchange programs with different universities from all over the world. Makerere is an equal opportunities and gender-responsive institution. We guarantee students' safety by providing accommodation in 12 self-contained affordable halls of residence within the university and several affiliated hostels outside the university for both male and female students. Makerere has an enabling environment for student study. At Makerere, we value sports because sports helps students and staff grow intellectually but also keep fit. We have quite a number of sports here. With our better understanding of health and its impact on learning, we have a team of trained staff that not only treat, but also intervene appropriately to counsel and guide them on health matters and emotional struggles. Your physical challenges should not limit your access to Makerere University. We have facilities and programs that enable you achieve your dreams. Makerere University is no longer the ivory tower she used to be. From north and south, from east and west, Makerere University welcomes all those yearning for a quality higher education, producing professionally grounded and versatile graduates. Because we build for the future.
Hi there. So you learned a lot about the University of Makerere. And now we will talk a little bit about the Inspire Hackathon, I think. And Karel is joining us in this room. You are muted, Hanka.
Sorry. Karel, could you please raise your hand?
He has.
Yeah, perfect, perfect.
Hi.
Hello, Karel. Yeah, I have a few questions on you and Bente.
Okay.
Because I actually joined this Inspire Hackathon train a bit later than you. So I want to ask you, Karel, what made you come up with an idea of Inspire Hackathon concept, and when was this idea born?
Okay, I think that it was not one moment. Yes, it took some time. In reality, we organized some hackathons already before the first Inspire Hackathon. Then came the idea to go and organize one hackathon on Inspire conference in Barcelona. This first Inspire hackathon was in reality in situ hackathon. Yes, so the coding was done during the hackathon in 3 days. But one thing what I recognize is that to do this on this Inspire conference, we were a little limited with the number of people who entered this Inspire conference and who was able really to cooperate. And also 2 days, okay, it is 1 day, 1 night, 2 days, but usually it is a short time for some bigger work. Then we decided for next Inspire conference, which was in Kiel and Stuttgart, to organize already this event from big part virtually, where the teams work virtually for 1 month and use Inspire conference only as the place where the results were presented. But then we recognize other things, that usually if you don't continue more often, the teams disappear, some connection which was established are broken, and not very often they will continue. Other things what I recognize during my now more than 20 years working on a European research project was that On one side, every project is starting with very similar model, yes, user requirements, design, implementation, testing, and in reality, on the end, you finally know what you would like to do, but the project is finished and team is broken. And we start to thinking that it will be good to guarantee some transferability of the result from one project to other, and also some continuation. And we were focused more not on the hackathon so much with the students, but people from different projects working together and be able to build something bigger and transfer this from one project to other. And we start organize this regularly. Last year we decided to try to do this with Africa. It was a first big challenge, and now it is such that it is running. And every time I'm telling, INSPIRE conference is not event; it is process.
Exactly. Thank you very much, Karel. Thank you.
You're welcome.
And Bente, I have a question on you. When did you join? When did you join this INSPIRE hackathon movement, and how it happened?
Yeah, well, I think we can blame you, Karel, in combination with a partner, a colleague from SINTEF, Norway. It's a big research institute dedicated, well, a big part of it is ICT, so international communications technologies. And so what, at the time, it was the end of the pioneering citizen science observatories, which is unique for Europe. And the idea was, as Karel said, to have a continuation and to ensure that this will not disappear after the end of project. And there were a set of new citizens observatories starting as well. So that was sort of the starting point. So that was in Barcelona in 2016. So from the very first INSPIRE hackathon. But I guess so that the concept that you communicated, Karel, or at that point, was to have a continuation from...
sorry to interrupt you. Lydia, could you please mute your microphone? Thank you. Thank you.
Anyways, I will not spend so much time. It was I was captured already because making data interoperable, that was a big issue, a big thing. Promoting geo Earth observations, so geo and GEOS and Copernicus data was also an important thing. And of course, the INSPIRE directive with the interoperability was is something that I was working with anyway. And the hackathons and the development of the hackathons and this inclusive way that Karel, and we really have to tell, Karel is the unique builder of communities. So he convinced a whole bunch of people, and he still continues to do that. And I'm very happy to be a part of this movement or community that is constantly evolving. And the last two ones in Africa, in Nairobi, and now in Kampala, is just amazing what we can do when we are joining forces.
Yeah. Thank you very much, Bente. Thank you. So I think we are maybe ready for our announcement.
Yeah, I'm ready with this. And Lydia will be our spokesperson. I think we will start from number 3, right? The top 3 is being selected. And before you start, don't leave until you hear what the awards is. There are some awards in this fun part of the hackathons. So stay tuned. Lydia. Now you need to unmute yourself.
And kick Karel out, please, Bente. Thank you, Karel, for the interview. Thank you.
Okay, thank you, Bente. And thank you, everyone. Thank you for hanging on up till now. Yeah, as you have heard, my role is to announce who is who, but I'll start by, thanking you for being here for the 3 hours, coming up to 3 hours. I know the video has shown some parts of my appreciation, There's a team behind this whole thing, behind Bente and Hanka. We are grateful to those members. We are grateful to the mentees, you know, for pulling this through, but especially the participants in the various challenges. It has not been an easy period with the corona, COVID-19, anxieties and stresses everywhere. Thank you for pulling it up to the end. So as Bente mentioned in the beginning, that this is not a competition, but a friendly competition. And of course, yeah, when competition happens, we really celebrate the kind of competition. So I take the pleasure 3, and that is challenge number, maybe not challenge number, but climate change trends in time. The second winner.
Pavel, it's you.
And climate change, that's Pavel.
Yeah.
See. Is Pavel still here?
Yeah.
Yes, he's here.
Yeah, that was challenge number 6. The second winner, and I must say that the winning has been quite competitive also. Like they have scaled almost, you know, the margins are quite limited. I will not say how much, but, you know, they are quite close. The second winner is SmartAfriHub, challenge number 2.
Yay!
Yeah, thank you, SmartAfriHub, for participating and coming out excellently. And last but not least, our first winner is the Desert Locust Challenge. And yeah. Thank you all for participating. We are all winners, as we have said now and again. This is just a celebration for, you know, a thumbs up for those who we feel have come out best. So thank you, everyone, and back to you, Bente.
Yes, thank you. Great.
Thank you very much.
Yes, great. So this is the end of this hackathon, and I'm glad we managed to include the assurance of Karel that this is not one event, it's a process. So there will be several Inspire hackathons. So for all of you who participated here, please join us again. Well, I promise that you should have some awards. This is fun, as we try to make it as fun as possible, but also useful for you. And we are very happy that Godan is offering an opportunity for all the teams to publish their report in the gateway, the Godan gateway. And I will actually include a link to that so you can see what it is, but this is something that you can use for some of you to elaborate even further, and you get a DOI. Maybe you will say a few words about this possibility, Sushit, since you know it so well.
Okay, yeah, thank you very much. I want to just first of all thank you all these participants and all the mentors. You know, it's a huge amount of volunteer work, and we really appreciate the time and the efforts you put in to make all this possible. So from my heart, all thank you to everyone. You're all winners in my perspective. So it's really appreciated. And what we want to make sure is your work is this is not the end of it. It's just the start of a process of learning for all of us. So you have not only the reports, but your presentations also. We will make sure you get opportunity to have it uploaded with the DOI and all aspects. So Bente has put the link of the gateway. So we will follow up with you to make sure your reports, the final reports, are also published with the DOI in the gateway. So
yes.
I will look forward to work on that. Thank you.
So some of the reports will need some adjustment to meet the requirements, but there are not so heavy the requirements. Is that correct?
Yep. It's like a report, documents kind of aspect. So, but we will send an email later to follow up on that.
Excellent. And something that everybody will also get, we will get to the top 3, will get something extra, but I want to share with you a small token appreciation that you will all receive. Actually, I will just show it to you. Just hold on. And you should be able to see here, you get a certificate of appreciation for joining this community and participating and contributing to the work for a sustainable Africa. That is actually our goal with this hackathons, the Kampala hackathon. So this will be issued to each and every one of you that participated in the teams, and we will ask the mentors for help to identify exactly who you are. So that will come to your inbox with your name on it, not the John Doe or a Jane Doe. It will be your name on it. So I will then unshare. You will get this. So this is for everybody. Now, as you probably understood, this we are doing these hackathons in order to create a community and to contribute to a better world, nothing less. And for that, we need to maintain the communities. And part of that, it will be to share information about what you have done so far. So to create some awareness of our efforts, our joint efforts. And Ian, he is working in the group on Earth observations. Sushit and I, we are both members of the program committee of the group on Earth observation, and we will like to write an article on the group of Earth observation so that all the global community can learn about the efforts that we have done here, and particularly the top 3 teams. And finally, and particularly to number 1, we would like to help you and support you in identifying a publication outlet so that you can get a refereed or any other type of publication that is relevant for you. We didn't know who was going to win in the beginning, so we don't know exactly we don't have the journal identified, but the team behind this hackathon will like to help you with that, so you can use that in your future career as well. So those are the awards. We will, of course, write about this on our outlets, also on the Plan for All blog. And also, I'm sure you will do the same on the Godan platform, Sushit. And we discussed, yes, and the University of Makerere, we also discussed the possibilities of finding the right outlet in your network as well, right? Yeah.
Yes, Bente.
Yeah. So the idea is that we are supporting each other. We are sharing the efforts, the information about the efforts, because that's the way we can also attract new people who we want to welcome into this open community. It's all about open data, open source, and open community. And I know Sushit is agreeing with me to build capacity and to develop capacity for all of us. And it's not only for Africa, just to say that. I think all the Western countries also need to develop capacity to benefit from all these data that are now being made available. Yes, so that was the finale. Please stay in the community, follow us, Plan for All on and Guldan and the group on Earth observation, the University of Makerere on social media to stay tuned to what we are doing next so that you don't miss the next Inspire Hackathon. Do we have something else, the jury members? We are so grateful for you to the work that you did. Do you have any comments in addition to what I've just said?
No, just thank you from from my and all to you, to Bente, Hannah, who organized this whole thing. So much work has been done. So our great appreciation for you both to coordinate this whole hackathon to a successful completion. So I hope we will continue on building up this community, as you rightly pointed out, and help us move forward in new directions in the future. Thank you.
Thank you.
Thank you, Sushil.
And from me, I just say thank you for involving me. It's been an honor. Saw some great work, great teamwork, and really look forward to seeing where this goes.
Excellent.
Thank you. And Lydia?
Yeah, I'm also happy to be here, to be part of the jury, to be part of the whole hackathon experience. Yeah, I pledge to include more of my university students and staff, because it's quite, it's a good learning and networking environment. Thank you for all the preparation, Hunter and Bente. We are quite grateful.
Yes, thank you. And a big thank you to all the 18 partners, who is behind this. And in your program that you got, you can read more about them. There's a clickable link on each of the icons, so you can learn more about the partners that are involved in this. It's a joint effort.
Yes, okay. They helped us to make this happen. Yes. And also the jury, participants, mentors. So a huge thank you. Thank you all.
Yes. And it's 15:03. This is not bad. We are going for that.
We made it. We made it.
This is not bad. So with that, I think we can take a break and see you the next time. Okay? Bye-bye.
In the next hackathon. Bye-bye.
Bye-bye.